Gonna get started. My name is Victoria Moore. I am one of the admission counselors at Olin College of Engineering. This is the faculty panel. I'm so excited that all of you are here today. I mentioned this right at 7, but a lot of you weren't here yet. We are recording this event, just letting everyone know. And I'm going to let the panelists introduce themselves. So what's gonna happen is we're gonna do some brief introductions and little segments about each of our panelists, but this is mainly a Q&A driven event. So start asking all of your questions that you have for our wonderful panelists in the Q&A, and we're gonna spend the bulk of that time answering those questions. So feel free to start asking away, and I'll be reading them out loud. And take it away.
That's me. Hi.
Yeah, we're starting with you, Scott.
Okay, great. We just decided last minute that we're going to go anti-alphabetical order by first name, which put me first. So, hi, my name's Scott Hersey. I'm an assistant professor of chemical and environmental engineering here at Olin College. I've been here for almost 5 years now, and it feels like much longer. I've found a pretty awesome home at Olin and feel like it's been a really long time. My background is in environmental science and engineering. I thought I wanted to be a doctor when I was in undergrad, and was allured by environmental sciences, and first was ecology and evolutionary biology, and then environmental engineering. And really there is kind of this motivation to achieve impact in the environmental realm and addressing some of the major problems that we're creating as people in the world. So when I graduated at Rice University, I went to Caltech for grad school and I studied atmospheric chemistry. So kind of the chemistry and physics of how air pollution forms. And if you know much about Caltech, you know it's a pretty preeminent R1 institution with lots of resources and money, and we'd fly $5 million worth of instruments around in an airplane for a month at a time and study air pollution and mostly Western American and European cities to understand more about the air pollution there. Which was cool. A lot of great work that we did and understood more about the sources and mechanisms that transform air pollutants. But then after that, I actually spent 3 years living in a township outside Johannesburg, South Africa. And my wife and I did work together in the community development space, so community-based participatory development work. And we did a lot of youth leadership development, and then also started a social venture, social enterprise business, making nut butters, which is kind of random, and would love to talk about that if you're interested. But the other thing that I did is study air pollution in townships and informal settlements. And it was a model of research that really was trying to make the most out of limited resources on continental Africa. There weren't $5 million worth of research instruments for air quality on the continent. And so we had to get really creative and do this work at the intersection of sort of community-based development work with policy and engineering and science all at the same time, and in a lot of partnership with folks in the elected official realm and nonprofits. And it was focused on understanding what are the sources of air pollution and how can we actually reduce the burden of air pollution in these townships and informal settlements. And I learned a lot from that model in South Africa and really brought it to Olin and run the Air Partners group at Olin College. And the Air Partners group is basically modeled after that work that I did in South Africa. So we use the tools and resources of engineering, science, atmospheric chemistry, human-centered design, and policy work and advocacy to reduce the burden of air pollution for environmental justice communities in the Boston area. So that's focused mostly around Logan Airport, which is a major source of ultrafine particles. It's the most dangerous component of air pollution. We set up the country's first community-owned air quality monitoring network in East Boston, and are working on legislation with elected officials in East Boston right now to really codify a lot of the air quality monitoring and also the mitigation work involving free HEPA air purifiers in classrooms and residences there. So still a lot of air quality science work and a lot of really nitty gritty electrical engineering and data science and mechanical engineering work that all goes into making that a reality. But it's all impact driven. And the other thing that I do at Olin, I teach standalone courses in environmental science and engineering. I'm also the director of our senior capstone program in engineering or scope, which is one of the options for your senior capstone design. And that is those are projects that you do with external partners, and really that's the focus of that is generating value for external partners while having a deep learning experience as a team of students and developing as people and sort of this personal and professional development while you're creating value for an external partner. So I do that in scope, and then also advise teams in affordable design and entrepreneurship, which is another of our capstone programs. So that's kind of my world is how can we have external partnerships with Olin and generate value that makes a difference in the world. So I'm happy to talk about any of that stuff, but want to pass it on to my pretty amazing colleagues. And I think reverse alphabetical order would put Jason next.
All right, thanks, Scott. So I'm Jason Woodard. I'm also a faculty member at Olin College. I'm an associate professor of engineering and entrepreneurship. I teach our modeling and simulation course in the fall. That's a first year required course, interdisciplinary math and science course. In the spring, I often teach a course called Products and Markets with Debbie and others, which is our foundational entrepreneurship course. I'm also advising capstone projects with Scott and Alisha, which is super fun. So wide range of things. I love seeing students from their first semester through the last, and a few other times in the middle. As an associate dean, I'm working with the folks who think about our external engagement efforts. How does Olin connect with other institutions? How do we learn from other institutions, and how do we create opportunities for institutions to engage with us and learn together about how to rethink not just engineering education, but engineering, but education and engineering more broadly. So that's been a lot of fun. We run programs for other faculty members and create opportunities for faculty and institutions to engage around the world. So that's kind of what I do at Olin. How did I get here? A pretty circuitous route geographically and professionally and intellectually. When I was an undergrad, I had no idea what I wanted to do. I took courses in physics and philosophy and Turkish and a bunch of other things. Eventually created my own concentration in information technology and society. I would point out that creating your own concentration is something that every single Olin student can do. It was kind of a weird thing when I did it and where I did it in the mid-1990s, before most of you were born. Makes me feel old. But it set me on a path to really think about kind of interdisciplinarity as a core part of my intellectual identity. I went out and worked for IBM for a couple of years in the early days of Java technology out in California. And I was kind of a bridge between IBM and our partners out there, as also a bridge between the technical folks and the business folks. So that was interesting, and this was the late 90s tech boom, first internet boom. Really exciting to see what was happening, and also I was totally I had no idea how to even understand all of the weird things that were going on. And I had lots of questions about how technology works and how economics and competition and strategy and business and all those things. And so I somehow thought that going to grad school would enable me to answer some of those questions. So I went to grad school in a program that didn't exist when I got there. This is a program that was jointly between Harvard Business School and the Division of Engineering and Applied Sciences there in information technology and management. So again, the theme of kind of bridging disciplines and creating new programs. So I got to study all that stuff, realized that the disciplines of economics and computer science and business and others couldn't really answer the questions, or couldn't answer the questions that I wanted to answer. So I spent about 7 years creating tools, modeling and simulation tools to try to answer those questions. That's sort of an ongoing quixotic quest. But that was what set me on a path academically to try to think about how technology evolves, how do platforms emerge, how do we think about creating value in a technological landscape and a consumer landscape in which things are constantly changing. So how do we think about just very dynamic sorts of worlds? So that was kind of actually what I was up to. I ended up during grad school moving to Malaysia. My wife had an opportunity there, so I followed her, and then she followed me to Singapore. After that, she still works in Malaysia, but remotely mostly. I took a job at Singapore Management University, which was at the time a relatively new institution. It was founded around the same time Olin was, around the year 2000, and I got to be part of creating a school of information systems inside a new kind of American-style management-focused, social science-oriented institution. So I was kind of one of the more technical people there in a more social science-y place, which was kind of fun. Spent about 10 years there and ended up back in the US, partly for family reasons, partly also just having the opportunity to be at Olin. And I see one of the questions in the chat is like, why did you come to Olin as opposed to any other place? I'll preemptively answer that by saying when I was looking at opportunities to move back to the States, everybody I talked to had a slot. Everybody said, okay, can you teach business analytics? Do you do big data? What do you know about machine learning? They've got a very narrow sort of thing. And the job interview process at Olin involves talking to lots and lots of people. And every single conversation I had was a different direction of like, wow, it would be so fun if you could do X, Y, and Z. Or what about this? What do you think? You could teach a course in that. You could do some stuff with students. Here's a project. Here's an opportunity. There's a thing at Olin called opportunity overload. So I experienced opportunity overload even in the job interview. And it turned out to be a very good fit. So the past 6 years that I've been at Olin has been really fleshing out all of those opportunities and getting overloaded by them. But it's been super fun, really enjoyed working with students and getting involved in the leadership of the institution. And I think that brings us to Debbie.
Great. So I'm Deb Chachra. I think I am the grizzled veteran of the four of us. I'm a professor of engineering here. And I joined Olin when the very first class was started in the sophomore year. I see my cat Leroy would like to be introduced. So I started Olin, the very first class was started in the sophomore year, which is the year I started. And you know how we always talk about how Olin is a place where we're reinventing engineering education. And it turns out that for me, it's been a place where I've had the opportunity to reinvent myself and the work that I do kind of over and over again. Which has been really fulfilling. So I started off my undergraduate degree. I grew up in Canada, in Toronto, and I did all of my degrees at the University of Toronto in engineering physics. My undergraduate thesis project was working on the Sudbury Neutrino Observatory for someone who later, about 5 years ago, won the Nobel Prize in Physics for leading that project, which I remember calling him up and saying, like, I want to be involved in this project. It's super cool. So I started off in engineering physics. I then moved into biological materials, and I did all of my graduate work looking at bone and osteoporosis and understanding how bones break and heal. And then I took the work that I did, and I did postdoctoral work at MIT. While I was at MIT and thinking about what I wanted to do next, I went to a talk by a faculty member at Olin who was talking about this cool new engineering school that was being built, and really emphasizing that it was about working with students as well as doing research. And we were thinking about shaping an institution to change engineering more broadly. And I was like, this sounds like the kind of thing that I would really like to do. I like teaching. I like figuring out how to make institutions work better. I like doing research. I would like to do all of these things. Fortunately, Olin agreed with me. And so I started here. And you can tell from the fact that I have been here since then that it certainly agrees with me. And I've been extremely happy to be at Olin since. So when I first came, I came with my background in bioengineering, and I spent much of my first half a dozen or so years helping to figure out the curriculum for the college and figuring out what the systems are would work for students. And as part of that, as many people at Olin do, I became increasingly interested in education and understanding the engineering student experiences, basically the experiences that our students have in education. And I have a particular interest in gender and STEM, and the experience of marginalized students. So at the end of that sort of first round of who I was, I got funding. I got an NSF funding to do research in engineering education, and spent the next 6 or so years working on that, understanding how things like our first year engineering design courses affect how students feel about their ability to be engineers and to be successful in engineering. And again, I'm happy to talk more about that if people are interested. So the next thing I did was I started thinking and writing more about engineering more broadly. And at the moment, and so that included things like engineering design. So the projects that I'm working on now include being part of the sketch model grant that Sarah Hendren is leading up, that is about thinking about how the arts and the humanities fit in engineering. And that involves both the student component, and we bring in people to Olin, and we're thinking about how that can lead to curricular change. The other main thing that I'm doing right now, besides courses, which I'll talk about in a second, is I'm writing a book about infrastructure, and I'm interested in how infrastructural systems shape our lives, but also how they're going to need to change to bring us into a future, one that is sustainable, that these systems are resilient, and understanding sort of the role that they play in our lives and why they're important. So those are the things that I do sort of in the broader intellectual space. The way that's manifested in my interactions with students is that I started off teaching material science courses and biomedical materials courses, which is sort of what my field was. And then I moved pretty seriously into engineering design. So for a number of years, I teach our first year engineering design course, Design Nature. I've taught our second year course, which is user-oriented collaborative design. And then I started teaching products and markets, as Jason mentioned, which is nominally an entrepreneurship course, but is really about developing, or not really, but is also about developing students and about learning a set of skills for different kinds of design. So I really see all of these things as very closely related. And then the other course that I teach is now I'm teaching an experimental first year course in infrastructural studies, so that engineering students can kind of learn about the water that they swim in, understand how these systems shape what they do, but it's a humanities course, not an engineering course, to think about those things. So those would be broadly what I'm interested in, and I'm going to turn things over to Alisha, but we're all, of course, happy to ask and answer questions in the Q&A period. Alisha?
I'm tempted to say a lot of things, and I'm tempted to keep this really short so we can get to the questions, because I've been scrolling them while people talk. So I came here about 2 years after Debbie. So you're like a seasoned old timer, but I've been here at Olin for about 15 years, just a teeny bit. I started in chemical engineering because I was good at chemistry and didn't know what engineering seemed applied, and that seemed cool. But from there I found bioengineering because the idea of doing something that was really applied in the area of health felt really compelling to me. And so for a while I was in the tissue engineering space, and Debbie and I actually had a lot of common overlap in this sort of cell material, wow, interaction, sorry, it's been a long Zoom day. And like other folks have been saying, I have sort of had a very wending path. When I was a postdoc at MIT, I was very convinced that I didn't want to go into teaching because I'd been at really big institutions where teaching wasn't valued, and it was terrible as a student. And so I was looking for a job in industry. And I also went to a early talk by one of the founding faculty and had heard of Olin. And someone I knew said, oh, well, they're looking for someone to teach a few classes. And so I was like, oh, that sounds kind of neat. I'll go do that. And I came and I was expecting them to say, like, here's the textbook, here's the class, teach it. And instead I was told, like, well, what do you want to teach? And I was like, I'm just a postdoc, I don't know. And so I think, you know, people have been asking, like, why did you come to Olin? I didn't go through a formal process, but I have been here this long, and I kind of can't imagine going into one of those, like, here's the things you teach. And because I've taught so many things, I've developed 7 or 8 classes all on my own in the bioengineering space. And they used to be much more in that cell material interaction space. And lately I've really shifted into design. I've done capstone for a long time, also teaching capstone currently with Scott and Jason, and do a lot of work in biomedical device design, both in capstone and in a class that I teach. And so I've had the opportunity to really follow my passions and grow and learn. And so that's one of the greatest things about being a faculty at Olin, is that I'm always learning new things. I've taught in the sophomore level design class, several other classes, part of teaching teams. And increasingly, I mean, starting in undergrad and through grad school, I've been doing work in the area of equity, inclusion, diversity, but that's something that's become a much bigger part of my world at Olin. I, like Jason, am an associate dean, and a huge part of what I do is think about equity and access. And I saw there was a question about sort of neurodiversity. One of the things that we've spent a lot of time on in the last few years is looking at how Olin's specific approach to education, some of the practices that we use, in many ways are really, really awesome for a really neurodiverse student population. And we've also been thinking about ways in which some of the elements of what we do aren't supporting some students as well, and thinking about how we can sort of further support them. So that's been a really active conversation, just sort of to flag one of the questions that I saw. I'll stop there and let's get to the questions.
Thank you so much, everyone, for talking a little bit about yourselves and how you got to Olin. As I'm sure you saw, because a couple of you mentioned you were doing some scrolling, you've already seen some of the questions. So I'm going to start with one of the first ones we got. What are some things that make Olin different from other engineering colleges, in your opinion? I know it's kind of a broad question, but maybe if you each had to sum up what you think, you know, the key difference. Maybe we'll start with Scott again, if you're comfortable answering.
Yes, sure. I don't know really where to start with that. I'll rattle off some things. You know, I think at Olin, one of the things that is very different about Olin compared to places where my colleagues teach is the focus on people. That oh man, there's awesome Zoom bomb back there on Alisha's screen. So yeah, there's a very authentic focus on people and the implications of engineering for real people. So there's a saying at Olin that engineering starts with people and ends with people. You know, when we have students that start in their capstone projects and some corporate sponsor comes and says, we want you to create a device that does XYZ, our students almost invariably the first thing they ask is, who are the users and what do your users think, and what do they want, and what do they want out of features. So I think that's one thing. I think another thing about Olin that's very different is that at Olin we treat you like an engineer from day one. So you take a course called Design Nature in your first semester, and you're doing design, prototyping, iteration in your very first semester. You're creating things. You're in the machine shop, and that's a very unique thing. I think generally it's understood that in engineering you go through this math science death march for 2 to 3 years before you can do any real engineering work, and at Olin you get to start that on the first day. The last thing I'd say is that at Olin you get to create value in the world while you are going through your education, as opposed to, I think, the general model being that you need to get an education before you can actually create value in the world. So much of our curriculum is focused on doing things that benefit people and groups of people and communities in the real time. And that's just, it's built into courses that you take and the capstone projects that you do. So I'll quit there. I'm sure Alisha and Jason and Deb have lots of other thoughts.
I'm going to take over from here. So Scott, you said that we treat you like an engineer from day one. And I would say that one of the things that really distinguishes the experience of being at Olin is that we treat everyone as an individual from day one. And you've probably gotten that. All of us have sort of talked about having, we have our own path, we do the things that we believe in working on, but that's true for the students as well. And part of that is just because we're small enough that we could have real individual interactions with students. But really, the bulk of it is that that's what we've committed to in terms of our education as a mission. That that we understand that the sort of, if we want our students to learn and grow as individuals, then the way that that can happen is to treat them like individuals, to think about what they find motivating, and then to allow them the opportunity to work on those things. And the best example of that is the emphasis on project-based learning. So not only is it that you're working with other people, but because often that means you have more choice about what you want to work on, you can work on projects and ideas and topics that you personally find interesting and motivating. And one of the reasons, I mean, we're happy to have you do that just because you like these things and you want to do those things. But we have a vested interest, which is that we understand that by working on the things that you care about as an individual or that you care about with your group, that will most likely lead to better learning outcomes, better educational outcomes, that you will learn more and you will understand more and you will retain more and take it with you. So the next thing I would say is that, to me, that really distinguishes the Olin experience is that it really is focused on the individual student and centering their learning around them on a student-by-student basis.
Wonderful, great answers, everyone. So we've gotten a couple questions involving research, what research you have open to students, how are students identified for research, how competitive is it to get involved with research at Olin? So a couple questions in that realm. If anyone wants to start? I can just pick on someone.
I can give the overview. I'm not actually doing a ton of work with students right now because of my various roles, but in general, for the folks that are doing research, it's a small community, so people kind of know. But really, like, it looks like, hey, Scott, I'm a first year. I'm interested in doing research. Do you have any research going on? Like, I think your work's really cool. I mean, it's sort of reach out and have a conversation. And I don't think it's not super competitive. I think occasionally in the summer, there's a limited number of slots around funding and allowing people to stay on campus, but like, it's pretty much not only sort of faculty driven research, but I sometimes have students who say, you know, I'm really interested in researching X and it's kind of near your field. Can you kind of be a mentor around this? And that's always really fun. Someone was asking a question in the chat about like learning new things, and I was realizing some of it's like me going and learning new things, but so much of me getting to learn new things is the projects that students work on. And I'm always just like, ooh, yeah, I want to help with that project because then I get to learn about that, you know, sort of learn vicariously about that topic.
And I guess I'll just chime in to add that research is a well-established category of things that students do with faculty over the summer. There's all sorts of stuff that students also do with faculty, not only over the summer, but during the year, including curriculum development, sort of course design stuff, increasingly with other institutions. So we're looking to create opportunities for students to work with companies, with other colleges and universities who are trying to do new things, to really work as partners with them. So we run a program called the Summer Institute that brings faculty from all over the world to Olin. We had the largest student involvement in that ever this year, partly because we were virtual. So we were forced, so there's a question, how did COVID-19 affect us? Well, yeah, we went virtual like everybody else. Going virtual for this particular program gave us opportunities to bring students into this process, and that we hadn't been able to do because it occurs in a time of year that students just aren't on campus, so we hadn't had students involved. So there's all sorts of ways for students to get involved beyond traditional notions of research in creating, experimenting, co-designing things with us.
Great, thank you. We also had a question about what scope projects students have done in the past. If you could speak a little bit about that.
I typed out a little bit, you know, Alisha has much more scope history than I do, despite me being the current scope director. There are between 12 and 14 scope teams every year of 4 to 5 students, and those scope projects range all different disciplines, from robotics to human-centered design and electrical and computer engineering and software development. I gave a couple of examples in the Q&A. You know, we have hardcore data science projects where a company comes to us and they make for example, an audio device. We had a project with Sonos last year that makes speakers. They test these speakers and they generate a whole bunch of data based on those speaker tests. And so this was a data science project focused on adapting some machine learning processes to understand more about the testing and whether they could use existing data to determine whether a speaker was bad or good, and save a lot of humans in a box listening to a sound type of work. We had a project with Arthur G. Russell last year that's a company that does vibratory feeding. It's really intense theoretical mechanical engineering work, and it's these plates that like move things along in an assembly line. And they developed a new method for kind of doing and testing that vibratory feeding. And this year's a continuation project to add a different kind of impulse into that system. And so there's a lot of theoretical mechanical engineering work that's associated with that. We have another team this year that's focused on developing an antenna control unit for ground-based antenna to track satellites for better broadband connection in developing world contexts. So that's kind of robotics, mechanical engineering, electrical engineering. So there's a theme of a lot of our capstone projects that they are often interdisciplinary because real engineering problems cross disciplines. But Alisha, Jason, Deb's taught in scope too. I think all of us could say a whole lot about projects. They're cool. I'll stop there.
Maybe I'll add the two projects I'm supervising right now. One is from Boston Scientific, which is a medical device manufacturer, and it's this pretty technical, help us think about the next generation of this particular endoscope by understanding users, but really they want a mechanical design with some prototyping. And the other one is probably our most out there design project. It's from Ford, the design wing of Ford Motors. And it is really thinking about what the future of mobility post-COVID will be. And I'm also helping with the Arthur G. Russell, which is just really, really design this really technical thing. So you name it, we've probably done it. I wanted to jump on interdisciplinary. We talked about interdisciplinary in scope, but I saw there was another question there, and what do the classes look like? It's kind of like the scope projects. It looks like pretty much anything you can imagine. Every class is different depending on the topic, depending on the instructors and how they want to present that, but always very integrated, sometimes very intentionally looking at different ways of thinking that are appropriate to different fields, and sometimes kind of seamless because that's how the field looks.
Great. So we've had a couple questions kind of in the theme of how do the smaller class sizes benefit students' education, what the student-teacher dynamic at Olin is like, how that benefits the learning. So I was wondering if you all could speak to that dynamic.
I unmuted myself not to answer the question, but because I was tired of unmuting myself, so decided to keep it unmuted. So please, someone else jump in and answer that question.
All right, we're going to play check-in here on this one. I'm struggling to get beyond kind of the obvious answer is, hey, there's small classes, we can devote lots more attention, we can get to know people better. As Deb said, we can treat you as an individual rather than a faceless crowd. So that's certainly true. I think kind of getting beyond that, I would poke at what are the ways in which that enables us to do things that are fundamentally different in terms of developing students and developing kind of curriculum and thinking about education more broadly. I think our model enables us to be more experimental. It enables us to iterate faster. We can go into a course with a pretty good idea of what we want to do, but be able to be very flexible and responsive to what are people's interests, where are things going. When things unexpected emerge in the course of a semester, we can pivot pretty rapidly. Sometimes we do that because we try stuff and it doesn't work, and students tell us it's not working. You haven't been at Olin until your course is blown up and you've had to take a left turn because something happens. So that's part of the fun, but I think it's also part of the experience and part of the culture, and that's one of the things that's enabled by being not only a small place, but a small place that prides itself on being innovative and collaborative with students.
So one of the questions was like, how does it change the student's learning experience? And so the other thing that I want to add is that by having small students and by having faculty who are really focused on the student learning experience, we have a real emphasis on what I would describe what's often called formative feedback as opposed to summative feedback. So when you take a course, the point of the course is not what grade are you going to get at the end. And from us as the faculty, it's not like how quickly can I assign a number between 1 and 10 or a letter grade to the student's work. The end point of a course is not just a grade you get at the end. And so conversely, therefore, like most of our emphasis, so that's called summative feedback. You've done the thing, you got a number or a grade. What we really tend to emphasize is formative feedback, which is the feedback that you get on your work that helps you do the next thing, that helps you learn the next thing, that helps you carry on with your project. And so that's codified in a few specific places. So the first semester is pass no record. That means in those 4 courses, you don't get a letter grade at all. And that really enables students to emphasize, to both manage the transition to being a college student, but also because in that first semester, you're doing a lot of project work, you're doing a lot of design work, so things where there isn't really a super clear, like what do I need to do? What is an A? What is a right answer? And instead it's about learning how to make those decisions for yourself about what the right answer is. And the feedback that you get, the guidance that you get is really about helping you be better at that and less about telling you how good you are at that now. So I would say to me, from a student learning point of view, one of the real benefits of being at a small student-centered place is really that emphasis on not here's the stamp on your forehead that tells you who you are, but here's a bunch of information that will help you be better at what you want to be doing and what you believe in doing.
Thank you for the really thoughtful responses. That was great. Does anyone have anything else to add?
I was just going to summarize it as less hoop jumping, more focus on your growth. That's kind of I'm so uninterested in hoops, and I think that's pretty true of my colleagues as a whole.
Yeah, I mean, in scope, the key learning goal that we communicate on day 1 is that this capstone experience is about your personal and professional development. And there's not a lot of hoops you can set up to assess that.
Thanks. So we have a really great question that I wanted to present to you all. Someone talking about the transition from high school to college and how Olin works to ease that trip or support someone who might be having problems with that transition or having some trouble. And I was wondering if you could speak to that.
I can start. So one of the things we really do, and we've really firmed this up in the last few years, is we think about the first year experience. And that's really a collaboration between student life and the academic affairs. And we particularly work with the faculty in the first year to think about coordinating. And actually, Debbie has been our first year coordinator. Jason has been our first year coordinator. Scott, you need to do that sometime. But we think about that a lot. And so student life, it certainly supports sort of much more like on the social side and sort of academic support side. But we think in the pedagogy, in the way the courses are designed, in the way they are coordinated, in the way that we try to lower barriers to access we're thinking a lot about that. I think a lot of it is, there's a bit of a deprogramming that often happens for folks who've been in a more traditional educational system. To suddenly have all this freedom is a lot, and so we kind of try to ease people in. I'm sure others can say more.
Yeah, I'll just pick up on the point about the first year coordination kind of thing that we do. I'm teaching first years now. The amount of attention behind the scenes on both the overall student experience as well as the concerns that individual students might have, and the ability to address those concerns across classes. Like, it turns out that when you fall behind in one class, that's highly correlated with falling behind in other classes, and being able to address that, you know, by people who care about you. And we have lots of ways to do it, to kind of intervene gently and sort of check up on you and help you kind of develop the executive function skills you need to, you know, if you really need additional help, we have lots of resources to do that, and we will strongly encourage you to get that help. So being able to provide kind of holistic support is really helpful, and to do that in a way that's not punitive. It's really complementary to the education, because everybody who's teaching a first year course understands that first year courses are partly about being a college student. We recognize that, we embrace that. It doesn't take anything away from the content we're trying to teach. Those things are mutually reinforcing.
I'm going to add one quick point, which is that Alisha mentioned very briefly that the first year coordination is a collaboration between student life and the academic side. Every student who is admitted to Olin is capable of succeeding and thriving academically. If you're at Olin and you're having a hard time with that, it is not because you're having academic issues. It's not because you're not smart enough. It's not because you can't work hard. It's because you're dealing with the larger social context of what you're doing. There's something else happening in your life that is affecting your ability to concentrate on your studies. So for us to be like, oh, well, if you're doing badly in school, we're going to like work on what you're doing in school, that's not going to help you address the issues. What's going to help you address the issues is getting the right tools for the particular issues that you're facing. And that means that the faculty work closely with student life in order to make sure that we understand what our students need and help them find the help they need, so that they are better equipped to deal with their life generally, and therefore that will set them up to be successful academically, rather than doing it the other way around, which is, oh, well, we need to be successful academically, we don't care about everything else. If we know that your academic success really follows from having a really solid personal, social, emotional, cognitive grounding.
Those were all wonderful answers, and that was a great question for whoever asked that. That was wonderful. Pretty specific question. Are there any options at Olin to research areas of theoretical physics?
Certainly not with me, but that doesn't mean that it doesn't exist. We definitely have physics folks at Olin. I don't think anyone at Olin is involved with like Higgs boson type research and, you know, collider type stuff. I could be wrong. But yeah, I mean, I am not really aware. Is anyone else aware of that type of stuff?
No, but I was going to mention that in addition to being able to do independent study type research, that I've definitely had students who have research interests in areas that are outside of the things that Olin faculty do research at Wellesley, at Brandeis. I think I had a student doing research at Harvard. And so, you know, we're situated, well, when we're in person, we're situated in a pretty rich environment for various types of research, and you can always find something.
Okay, thank you. So some of you have touched upon this already, but I was wondering maybe if any of you wanted to expand. The question was, over the years, how has learning, teaching, and researching at Olin transformed your perspective on education and, in general, intellectual inquiry?
I like that Jason pointed in a direction and nobody knows what the order on his screen actually is.
Whoever's in that box, you can
Yeah.
answer.
Just some box.
For me, that's Alisha.
I was pointing at Debbie, actually. But.
I was waiting for Debbie to answer that one.
Yeah, I kind of was too.
Let's be real.
3-1, Deb.
I'm going to make sure I sort of recapitulate this, which is I interpret this as, how does your experience of being in the sort of intellectual and educational milieu at Olin, how has that shaped your own personal intellectual inquiry? Is that a good capture of that? I'm seeing some nods. So I think the reason why everyone is pointing at me is because I'm certainly the person who's sort of moved in the furthest number of different directions, or in the furthest direction. I more than anything else, I think I came into Olin. Actually, let me back up a bit. I started my undergrad. I was like kind of an engineer's engineer. My undergraduate degree is in fact in engineering physics, super theoretical. You know, I did kind of like serious research. I got a serious fellowship to do my graduate work. I went to MIT, and then I came to Olin, and then I realized that the thing I actually really cared about is the experience of students. And then I realized that the thing I really cared about is sort of larger issues of how technology is related to sort of justice and sustainability and equity and resilience. And that's how come I got interested. It's not even so much I got interested in infrastructure. I was like, I could explain how my local nuclear power reactor worked when I was like 11 years old. The thing that's really happened over the course of the last 20 years, and certainly the 15 years at Olin, is that I realized that what actually matters about these systems is not the technical piece of it, but in fact, how it relates to human lives. So Scott said that engineering at Olin starts with people and ends with people. And I would actually say that that is probably the biggest personal change in my trajectory. And that's really been sort of not just catalyzed, but really reinforced on a daily basis by being at Olin, because every day, all day, I think about the relationship between technology and people and educators and learners, and that's really become my main area of intellectual inquiry.
All right, so next question, some good questions that Alisha wanted to answer live or thought. Besides scope, are there any other major engineering projects to look forward to during a student's time at Olin?
I clicked that one, and I was also looking at the question above it, which was about, are all the projects open-ended?
Yeah.
I actually can't remember that there's like a general number of how many projects an Olin student will have done by the end of their career, and I have no idea what it is because it's a big number. And I think that's the point I wanted to make is not all classes have projects, many classes do, and they are open-ended or structured as appropriate to the learning goals and also sort of developmental level of the students. So I often think of an arc going from first year where the projects are fairly scaffolded. There's some really specific learning goals, and there's a lot of sort of help around the edges. And as you go up, progress to your fourth year, there's sort of more and more ability to craft that direction. But it really depends on the course and the sort of goals. Others can chime in, but that's sort of a big piece of what we think about when we're designing classes.
Everyone feel that that's covered? Yeah. Moderating virtually, kind of just giving everyone a second. Yeah. So as students progress towards the end of their time at Olin, what resources and connections are available to students for either going to grad school or finding a job and going into industry?
We have an office of postgraduate planning that's staffed by awesome people who are deeply connected with not just students and their stories and what they want to do, but also with industry and potential employers. We also have an office, and I'm blanking on the name of that office, that supports students into graduate school. Is that also PGP? It's also PGP, but it's a different person in PGP. Yeah, okay, got it. So yeah, PGP, postgraduate planning. they meet with students all the time. They've really got their finger on the pulse of things and get students connected with opportunities. And that's not just postgraduate opportunities, but also internships during your time at Olin, so summer internship opportunities. They even will assist students in finding opportunities to take a leave of absence and go work for a company for a semester or for a year while they're away from Olin. So yeah, lots of opportunities in there. Yeah, I think because of the extent of our connections outside of Olin, it's easier to make a lot of those connections because we already, we have these connections with Ford and Boston Scientific and GE Healthcare and all of these folks who work with us through the SCOPE program, as well as community partners through ADE. And so there's a lot of interplay, and it's easy to plug in. Our alums are also out in the world doing really awesome stuff, and their alums love Olin and love connecting with Olin students through career fairs, job fairs, that kind of thing.
And just to connect that to the earlier point about the small community, when you have faculty who you've worked with closely and who really know you well, they can write letters for you that are pretty persuasive. So that's a feature of being here. I have a student who's now at Carnegie Mellon who I wrote for, who came back to me for a letter for Microsoft Fellowship, and it kind of rolls on through people's careers, and it's really one of the things that's satisfying for us. I take a lot of joy in students who go out into the world and do a lot of different things, and it's great to be able to see them at different stages of their development.
Great point, Jason. And PJP is amazing, as has been stated. They're definitely great. So we had a question about, I know it was touched upon briefly, but I was wondering if maybe some of you could expand on how COVID-19 is affecting project-based learning, how teams are communicating remotely. If anyone wants to take that one away.
I'll take the easy part of that, which is the modeling and simulation course I'm teaching, which is fully remote. Would love to hear Scott and Alisha chime in on SCOPE a little bit. Debbie may have a perspective as well, because SCOPE's a super interesting one. The courses that we're teaching remotely, so I'm teaching a course that involves a project right now. Students are working with each other. It's a modeling, simulation, and MATLAB course. So they are using MATLAB, they are sharing screens, they're sharing code via the cloud. We're doing project presentations remotely with peer feedback. So on Friday, we'll all get into breakout rooms and the instructors will go from breakout room to breakout room. Students will be there in pairs presenting to each other and giving each other feedback. It's a virtual analog of what we do in the classroom. Obviously, there are things that we miss about the classroom, a lot of things we miss about the classroom. On the other hand, it's been surprisingly effective. I gotta tell you that the quality of the work this semester has been as high as any other semester I've been in at Olin, and people seem to be having a reasonably good experience at it. So the tools aren't perfect, and we certainly complain about them a lot, but they are managing to do authentic project-based learning, kind of student-centered stuff, and it's going okay.
While we're talking about first year classes, I just had a long conversation with one of the teachers, faculty who's teaching design nature, which is another one of the first year classes that has a significant hands-on component. And so many of our first years are on campus, some of them are not. And they're in household groups, and so they're able to work in the room, and they have this setup that is sort of the sci-fi futuristic setup that works. Maybe it is now. The future is now. But the faculty zoom in to the room, and the students are not sitting at their computers. They're all able to engage with the screen. They have the sound set up so they can hear. And many of the groups have a remote student in their group. And so the students just lives on a little tablet who can go and they can truck around the room. And they have all the sort of hand tools and prototyping equipment they need in the room, but they've also shipped that out to the students who are remote. And so everyone's able to engage in this very hands-on class in a very mixed media world. In SCOPE, we're meeting on Zoom. I mean, it's kind of convenient because the teams are sort of 4 to 6 students, and so you can meet in a Zoom room, and that part's going quite well. Workshop delivery is going really well. My team that's not building anything is doing great. they're really great materials for doing that work virtually. My team that's prototyping things, we've shipped endoscopes across the country, 5 of them. And when they're ready to build things, they'll have them fabricated at Olin probably. They can send work orders in and then we'll ship them out. We have a whole shipping system now. Yeah.
Yeah, it's, I'd say at Olin, we're generally pretty creative, flexible. It's a lot of cognitive flexibility to figure out how to do stuff. And we're figuring out how to run prototyping heavy scope projects too. And as Alisha said, there's a lot of elaborate shipping mechanisms and, trying to figure out safety protocols for soldering and building things in people's garages and things like that. So, we're paying attention to all of that stuff too. There's a lot of levels of complexity when you're not just designing something to be prototyped, but then also manufacturing parts off-site, getting them to students to assemble them, but we're figuring it out. It's still early, so you can maybe ask us that question again in like 4 or 5 months, and we'll give you a more solid answer.
I'm gonna actually throw in like 2 quick points. So one is, like, Olin exists because we are a place where we want to think about how to create new experiences and how to iterate and how to be experimental. And every student who comes to Olin understands that. So now everyone in higher education is dealing with something that they've never dealt with before. And we have kind of the signal advantage that we all know how to do experiment, and we all know how to iterate. Like, it's the thing that we actually do. So this is the thing that we've all kind of signed onto, and it's a thing that we have a lot of experience doing, which is good because we need it now. Because whether we like it or not, everyone is dealing with things for the first time. That's sort of the first thing from like the who we are as an institution. But the second thing that I think is at least as important is that we really trust our students, and our students have rewarded that trust. The honor code at Olin is a real thing, right? For 15 years, our students have been taking exams on their own recognizance without us proctoring them. It means that when we ask them to obey things like mandates around social distancing, they do, right? We believe in community. We understand that we take care of each other, and that they can be trusted to take care of each other. And that, more than anything, has really shaped Olin's response to COVID. And that's why we have 85% of our first-year students on campus.
I'll just pile one more thing onto that, Deb, because that's a great point. I did a workshop for another institution over the summer, elite, prestigious, maybe even Ivy League institution that was trying to think about COVID and whatever. And the biggest concern that came up from faculty was in the space of how do we make sure students are not going to be cheating on exams? Like, okay, if you're designing around trying to mitigate cheating on exams, you're in a very different part of the design space from how do we create a compelling student experience.
Thank you all for speaking so much in depth about that. This concludes our time. We actually hit 8 p.m. We do have a couple of unanswered questions, but I wanted everyone to know that we will address those questions via email for those that weren't answered. And this is being recorded as well. So I wanted to thank you all for coming. It was great having you. You had wonderful questions. I want to thank all of the panelists as well for taking time out of their days and evenings in order to come do this. So thank you all for being here. Have a wonderful rest of your day.
Thank you.
Thanks.
Bye, everyone.